welcome our second speaker. He is guru of event-driven architectures and also domain-driven design and significant contributor to open source community. So please give a round of applause to Mr. Alexey Zimarev.
Hello. I'm sorry for delay. You know, I've been spending a lot of time doing this code for this talk. Basically, that's the only slide I have. The rest is code, and I draw it just now, and because I was so nervous, that my latest changes won't work. And actually, the oldest change didn't work, but the newest actually worked. So I'm going to talk about actor model in the context of domain-driven design and event sourcing. I just want to have a quick question round. Who knows what domain-driven design is? All right. Who uses it in production? Okay. Event sourcing? In production? Even less? Okay. Actor model? In production? No one. Okay. Ah, you guys. Yeah. All right. These are my colleagues. That's why. We use domain-driven design, event sourcing, and actor model in production in different combinations. And I see it as a great success, and I want to share some of the things that we found out during our journey towards this kind of approach. So, since people are familiar with domain-driven design, that actually was expected. I thought that most people would know. So therefore, I'm not going to talk about domain-driven design at all. I'm going to talk more about event sourcing and about how actor model can be helpful in this. So what I want to do is it's really small now. I need my glasses. So what I do now is I'm starting a Docker Compose file, and let's look at the Docker Compose first. So I give you so you will see what I'm trying to start. This is the Docker Compose YAML file, and let's see if the Smart Zoom works. No, it won't. View Zoom. Oh, I'm really sorry about it because I thought that it would be easier to look at. I think this would work. Yeah, okay. So I have several containers in this Docker Compose file, and the main one is, of course, EventStore. And EventStore is the functional database only designed to store events. And I have some nice features that I will talk later. Console I need for the actors, because I will spin up the cluster of 2 nodes, well, actually 1. I would use RabbitMQ for messaging, to send some commands, just to see how it differs from the normal kind of command processing with the actor-driven command processing. And I have RavenDB to keep the read models, and I will talk about this later. And Prometheus Grafana I will not be using, because I couldn't configure the metrics properly. But it's not that important. I just wanted to show some metrics. But then I found out that if I show metrics, you will be disappointed, because my machine is so slow that you will say event sourcing is slow. And that's why I decided not to show you any metrics. So I guess what I need to do is to stop this one. Come on. Okay. And then I go to and start this component. Zero environment. All right. So here things start. So what I'm going to show you now is, okay, this is the window, hidden. So I suppose you don't see that either, right? Let me just find the presentation mode. Presentation mode. I'm afraid if I enter presentation mode, I will never be able to leave it. So that's a bit scary. Okay, I'll try. Okay, that's presentation mode. No, that is presentation mode. You see what's going on? So this is my first demo. It consists of 3 parts, and I will try to draw it and see if it works. Here we go. So what I'm trying to draw here, how this thing works. So let's assume that we have, you know EventStorming, any of you? Yeah? EventStorming is look it up. If you know domain-driven design, or you think you know, or you want to know, look it up. EventStorming is a brilliant technique. So in EventStorming, we usually show events with the orange sticky, right? And this says, customer registered. Yeah? So, but events is the outcome of some operation, so it's actually the state change. So before this, something happens, and usually what happens is we have a command, and the command says register customer, right? Sorry. That's fine. So this is basically the essence of EventSourcing into whatever, how to say this, into sticky notes, let's say it like this. So you send a command and you get an event. And, but how you do, what happens then with this? I mean, we all know that when in life something happens, we can register this fact, or we can write it down, and then we read it like a story or ledger, the Bitcoin-ish thing, ledger, very fancy. And then we can understand what was happening during this time. So we can put it in some sort of a ledger, and we will have ton of this sticky notes here, ordered in sequence. And they can tell us the story of this particular customer. If, like, for example, the customer ID here is customer ID was 123, we get an event stream that's called customer 123. And every event here tells us something, that this was registered, this was like name changed, this was moved to another address. This was, I don't know, credit limit adjusted. And this was like, okay, it's gone. And then GDPR, you need to delete everything since 30 days. Okay, so storing the facts in your ledger in some sort of a database linearly, it's just a collection of JSON objects or whatever objects you prefer. And recovering the state of this object every time you need to perform the operation and make a decision is actually the essence of event sourcing. So restoring the system state from events and keeping events as a source of truth. Nothing more than that. So let's have a look how it actually works. So here I have a few things. This one is actually a simple one. Well, relatively, again, I spent several days working on this really hard, so please appreciate my work, even if you don't like it. I have a domain model. The domain model is very simple. It has customers, vehicles that customers use, and every vehicle is supposed to have several sensors. So the domain model is simple, and therefore it doesn't show the beauty of the domain design whatsoever, but again, that's not the topic of this talk. I decided to just go overboard and created something that I call functional aggregates, which very much reflect the nature of event sourcing, and I will show you how this works. So basically, my maybe vehicle is not that interesting. Maybe or customer vehicle is interesting. If you look at the vehicle object class, it is a static class. It has several operations. It's registration, adjust max speed, because my idea was that the sensors send speed and temperature, and then you can register if the vehicle is burning or speeding. So you can have you can do something about it. Called if aggregate. But because every vehicle is different, you can say, okay, this is a Formula 1 vehicle. I don't want to set limit to 100 kilometers an hour, so you can adjust it. And then you can process telemetry for the vehicle. And telemetry is basically data that you get from sensors. And in this particular case, you will see that I make some decisions. So let's go from the start. Register, I put, what I do here is I create a new state of the vehicle. State is a collection of properties. And the collection of properties know how to mutate itself based on the data supplied in an event. And I emit, so I apply new events to that state. And it contains all the properties I got from the command or I know from somewhere else. Usually you get it from the method, you know. So you see that I got from outside world, vehicle ID, customer ID, make, model, registration, speed, temperature, and I apply that new event to an empty aggregate state. So I call it an aggregate. You can call it an entity, whatever. And the current state is just entered, registered. If I want to adjust max speed, I perform an operation called adjust max speed, and it gets an existing state, because in the first operation you see the existing state is not being sent because nothing exists. It is the first one. And then it applies an event saying max speed adjusted. If we go a little bit further, so temperature I wouldn't look at, but process telemetry is quite interesting because what I do here is actually making decisions based on what happened before, or not, what information I already have. This is very basic decision, but you can have some more advanced scenarios. So here I have, hence, C#8 switch expression pattern syntax. Really fancy. So if I got a state where speed, this detected speed, which I got here, is higher than the max speed of this object, of this vehicle, then I apply a new event saying vehicle speeding. And when I detect high temperature, I say vehicle overheated. If I would write another condition when the temperature is twice as much as the max temperature, I could say vehicle is burning. And this kind of stuff you can do in this object, and you can analyze what you know from before, what you received just now, and then you can say what will happen next. So these methods are actually command execution. So if we look at the vehicle state object itself, it's very simple. So it's basically a property bag. It has all these properties that I was manipulating. And it has this apply method. An apply method comes from the base class, basically. And then I need to implement this when. And when is when I receive certain events, what I need to do with the state. And I basically change it. So no matter if you apply an event when you process the command, or you apply an event when you actually just emitted it, it will be always changed state. And there is one more thing here, I call it contracts-based, whatever, programming, invariant checks, is that I have in every entity state, I have this contract that says about the rules. Like in this is very simple because there are no kind of states there. At least I require that ID should not be empty, customer ID should not be empty, and registration number should not be empty. Otherwise, it's true. But there might be more complex rules. Like this is this is my sample repository for the book, and here I have a little bit more complex rules over here. So for example, if the domain is classified ads, and if I cannot accept that the owner is empty, but if the ad is pending review, that it must have certain data available, and it cannot be published without being approved. So this happens when you receive a command, you actually apply an event, and then after the state is mutated, you check if the the state of the entity is still correct. So if I try to draw it again, you can just see if it goes. So many windows. Okay. Unfortunately, it keeps disconnected, but I will fix it now. So what happens there is that I send a command, do this. And this my aggregate, let's say. And then it will apply an event to itself, new event. First, it will, of course, read them from the store, from the database, EventStore, read, apply an event, then check the contract. So the sequence is like this: read all events, apply them, do, apply new event, 5, check state, and 6, persist. So that's basically the operation, and it looks like this in code. Let me just show you quickly. I'm lost. Here, yeah. So for something that actually needs to execute commands, you need some sort of an application service. And this is what happens in the application service. Let's look at the vehicle, because we were looking at vehicles anyway. So here we go. So I just call this method on the aggregate, and there is some magic happening. Not really magic, there is no magic, and very little dependency injection. I'm warning you, stay away from dependency injection, really. Yeah, this command service basically load an aggregate, you call a method, it will save it if it doesn't fail. So that's very easy strategy. It might sound a little bit cryptic, but if you look at the code, it's not that bad. You can see that all the operations are very small, and they're being executed in basically 1 or 2 lines of code. There is a little bit of work that needs to be done up front, but in general, it all works. So let's just run it and see what happens. So this is my, let's see, if, I cannot run a fem because it would be too slow, but I can run control FM, right? I will just do this out of fem. So what happens now, I use RabbitMQ for messaging, and this is my edge, so where I receive messages. And because of the theme, I cannot see anything on a terminal, so it's very handy. But I can definitely do this. So I can seed, this is my seed project. It seeds customers, and it seeds vehicles, and that's it. So we'll just run it. Run. Yes. Okay. Press enter. I will. Okay. And then seed vehicles. Okay, let's seed vehicles as well. So what happens here is that we have a bunch of stuff going on in, where is my browser? Ah, it's gone. Here. So, just go home. This is the interface of EventStore. It is quite loaded now because I'm producing several thousand documents or several thousand events. But you can see that there are vehicles being created, and the vehicle basically contains one event, and the event is registration. So it's very kind of easy to grasp. There is no fancy things going on. And I'm sending through RabbitMQ, and you can see that the queue has 46,000 messages, and it goes on a quite low speed. I wouldn't expect it to be that low, but because my notebook is overloaded with stuff, it goes like it goes. So, and then there is one more thing that we need to remember in event sourcing is basically what you see here is the list of events, right? And they all in streams. So we have this is the vehicle ID, and it has the stream, and there is one event, but there might be many events. There is no way to query this store. So then we do, we apply CQRS. Some of you that worked with EventSourcing probably heard of CQRS. It's command query synchronization principle. When you separate the place where you, or not the place, the method how you persist data for the, to make decisions and to make change mutations or state mutations, and you separate it from the place where you read the data, or the method. So you can use one database, you just separate the method. Some people use like entity framework here, dapper there. I never do that, but I would like, I persist to EventStore, and this is my transactional store. It guarantees all decisions are being taken correctly. But I can read from somewhere else. So how the hell are we going to do that? We basically project all these events to some other database. And this is what I do in code here. I will not draw anymore. It's horrible. So if you look at, this is commands, this is the client. It might, yes, no, this one. Queries, yeah, that's correct. So let me run that one as well. This project does projections, and I will show you a little bit how this works. When we let it run for a while, and then just go through the code. So you can see what happens now. The projection starts to read from EventStore and create what we call read models. It goes to RavenDB and creates a bunch of documents from it. So, okay, it's not easy to find a browser in this Windows here. So this is RavenDB. Can you see it well, or I need to change the theme? I'm not sure actually if I can do it. I don't think so. I think it's locked to yeah, okay. Never mind. So you see, this database was empty before, and now it has a lot of stuff. And for example, if you look at this guy, customer vehicles number 6, it has the customer information, a bunch of vehicle information. So it's important to remember in the world of CQRS and EventSourcing and in domain-driven design, when people try to implement EventSourcing, first thing they do, they say, I need to query my aggregates. How can I do that? I can't, so I need to create a read model. Well, now, you don't query aggregates. You only need to get your aggregate by ID to execute a certain operation to mutate the state and make some certain business decisions. If you need to query something, you usually need to show it on the screen. But the screen usually combines a lot of different stuff to present to the user. For example, you might have this situation. Oh, sorry. Yeah, sorry, return to my horrible drawing. Do this, and then I connect. It must be smoothless, but it doesn't work like this, but okay. So what happens is that this is your screen, right? This is your screen, and here is, for example, something is like, this is the customer name, and this is, for example, here is my burning list, and this is a small one. This is a speeding list, and this is all of them, vehicles, like, you know, and you don't get this information by querying your aggregates, or you need to query too much, or you need to create a bunch of models. What you actually need to do is you create one read model, preferably for the widget, or you can create one for the screen, you know, and it can combine information from several aggregates. What I've done here is, for example, this document, it has a customer ID and name, but it has all the vehicles. Okay? So you can actually show it on the screen straight away. You don't need to query anything. If a customer comes and says, I want to see all my vehicles, boom, it's done. You don't need to query anything at all. So basically this is, and this projection, this read model is built from two different aggregates. Actually, not from aggregates. Don't even think about aggregates when you build real models. They only project events. So I really hope that I get to the actors today. This is the query project. Where is it? I guess it's here. And it's still running because the RavenDB is not the fastest database in the world, and my computer is also not that good. So what I do here, I have this module called projections. And I have several of them. And this is, for example, customer vehicles projection, which actually tells you exactly what it's going to do. It says, I'm going to project vehicles for that particular customer on one document. So it handles two events. It handles customer registered, and in this case, it will create an empty document with an empty list of vehicles, you see? It's empty, and that's all it does. So when a customer gets registered, you create, so prepare. I hope that this customer just didn't come for us to kind of sell us something or to bug us. They probably come to buy some sensors, and if they buy some sensors, they will install them in the vehicles. So we expect them to add some vehicles. And the next thing happened, okay, they finally bought something from us. They installed a vehicle, or they register a vehicle in the system, and maybe they will even install sensors in their vehicles. So we need to add a new vehicle to this list. So basically, there could be tons of read models. In particular, I have two read models, and that's exactly what I was afraid about, is that I could not find my Solution Explorer. View, Explorer. Alt, yeah, okay. So this one, for example, also handles vehicle registered. You can have as many read models as you want for any combination of events, building the information you really need to show on the screen. And that's an important thing to do. You can use any kind of database storage. You can use Redis, like you do it for caching, but you always read and write. You can just write because you know that's updated by you only. And you can basically do whatever you want. It will save your life someday. You know? That's how the real performance system is working. They are not going to database and have like 20 lines of inner joins and outer joins querying all the time. It just doesn't work. But of course, it comes with a cost. A lot of events will be persisted. There will be a lot of data duplication. You just need to make the system reliable. Okay, this is the basic stuff. Okay, so then let's do something else. Let's go to actors. Let me kill this query stuff. I think it's still running. This is the commands, and I will have less things to care about. So this is the query. Let's close it. So it's still running. Terminate. Feel like a Terminator. And this is the. Actually, shouldn't have closed this one, but okay. I closed commands at least. Terminate. And I will restart the EventStore and everything, so we don't need to look at the data that was there before. We know that's clean. So now I'll show you what the problems are. So it's not all, field of roses. And there are things that we learned the hard way, and there are things that we knew, and we kind of haven't solved all of them, but we at least can give you some hints. Or like we are looking to my colleagues that actually were involved, and all these scars are shared between us. So let me just draw again. I'm sorry about this. It's probably even working now. Reconnect. Okay, so I draw this line, and I say, let's say this 1 million events. And this is really horrible. So what happens is, okay, when you write to EventStore, it always comes to the end, okay? So when you write it here, oh, damn it, I just don't really like it. No, shift. Okay, I will try to explain. Anyway, so what you have is that you have a bunch of events. So events. And then what happens, you apply it to, you send it to an aggregate, right? And then it produces new events. Or do you also get a command? Okay. And it produces new events. Let me just see if it will be better if I press enter. Yeah, no, it's not. You can see it at all? No? Okay. So when you do a command, you first read all of them, and then make decision, and then write. And you write new events. When every operation event sourcing produces 0, 1, or more events. Basically 0 or more events. Usually you produce 1 if everything is okay, and if there is an exception, you produce none. But it might be like you don't need to produce anything because you don't have to make any decisions, so you say just I ignore it. It's fine. But when you start adding more events, as I said, is very fast. You add to the end of the stream is basically writing to because it's optimized, especially EventStore is optimized for writing. Because it's a pen-only database, it always writes to the end, so it's extremely fast. It can go like 30,000, 20,000 events per second. I mean, it's not like Cassandra, but still very fast. Running on a laptop that's better than mine. But when you read, it gets an index on a stream, and it will read all events for that particular stream, and they can be spread across different chunks in a disk, and that can take a little bit of time. It's still fast, but not fast enough sometimes. So the more events you write to the stream for your aggregate, the more you need to read in order to actually recreate a state, before you can make decisions. People overcome this issue by making snapshots. So you read snapshot, and then you read several events after the snapshot. So then you kind of need to read less, but you can still read several of them, and you never read the last one. When you talk to the high-performance data processing people, they actually never read events. They only persist them, and they have projections, as I showed you, as a system state, and they say you never need to read. I say, how do you rebuilding the system? I say, we never tried, so okay. You can keep the system or the data that you think is a source of truth, but until you try to read it and actually rebuild the system from it, you probably will not be able to test if this is true. So the problem is that in order to make any decision, execute any command, you need to reach a bunch of events, then you need to make a decision, write one event. The same comes with, or similar problem comes with read models. So you have lots of events, and they coming to your system in a very high speed. But you can only have a single reader for that stream for at least one read model. Because the main advantage of event sourcing is basically you have guaranteed order of events. So the vehicle cannot be registered before the customer is registered, because first you send that command, and if you try to register the vehicle without customer ID, it will fail. But if you try use like RabbitMQ message bus, if you look at how read models were populated, you will see they're completely out of order. It's because they were published at once and then we processed them. So it's not a problem for that particular case, but it might be a problem for other cases. And especially when you build in read models, the ordering is very important. So that's why you have usually single-threaded, and it reads all these millions or billions of events continuously and try to build all these read models. It can become very slow if your database is not that fast. So we have two issues. This read can be extensive, and when you do the read models or projections, single-threaded. So the issue with this is that how can we scale event sourcing to the limit or without limits or whatever, so we can process more events. So we don't need to read events before making decisions, and we can actually scale out projections. I really counted that I can draw, but never mind. I'll start to fix it. So what we have here is, did I start it? I think I did. Yes. So I started Docker Compose again. So we have everything clean, and I have this thing that's called, let me close this one. Terminate. And this is the, yeah, that's the right one. I have the same, very similar service, a command side, but we're using actors. So I'm using Proto Actor. Let me show quickly to you what I mean. This is the website of Proto Actor. It's built several years ago. It's kind of modern. It was more modern when it was built, and now it needs a bit of revamp. I use it because we use it in production. It's the first place. The second thing is that it's a very small library. You can go and read it in a day and understand what it does. If you go and read Akka.net or Orleans, you can go now and come to me in a month and you tell me what it does. Even documentation for Akka is, you can spend weeks reading it and trying to understand. So this is a very simple framework, basically. There are a lot of details about actor model, how they work, and I'm not going to go into details there because many of the things that are benefits of actor model are not kind of fitting my use case. What I wanted to show, and I actually wanted to draw it, but I can't, is the following. When we have the actor model actually represents a bunch of objects in memory, nothing more than that. And if someone tells you that is more, it's actually a lie. There are more things that are surrounding the actor model idea. Not all of them are good. If you look at the Orleans, some of the things that are implemented there aren't that good. Some of them are really good. Every framework that implements actor model shines in a different way. But basically, actor is an object that is usually a stateful object that lives in memory for a while. You start it, and then it goes. It can receive messages and process some commands. And when the time comes, it dies, and that's it. Actors can be persisted, not persisted, so stateful or stateless. If you have a state, it's stateful. If you persist the state, it's persisted actor, I'm sorry. And there were talks in the community like, oh, that's nice. You have a thing that runs in memory, identified by a specific ID, unique ID, and I can talk to it. And I can tell you, okay, this is my customer actor or the vehicle actor. And I can tell you, okay, vehicle actor, please register yourself. And then vehicle actor, please process telemetry. And the vehicle actor say, oh, I'm burning. Oh, that's nice. So it looks like an aggregate to me. Well, you can't do that. I mean, there are a lot of people in this world that think this way. But what I'm going to show you is a little bit different. So what I think is that when you do your domain model, it needs to be pure. And then you can utilize port and adapters. So when you do that, you have a domain model that's surrounded by the application layer. So domain model is being called from the outside world. When you do actors being actually, they're processing messages. They deal with a lot of infrastructure. They actually deal with persistence. So then we have this, good old three-layer architecture, right? So you have a UI, whatever, application layer, and database persistence layer. It's basically nothing more than that. If you look at the onion architecture, it's just layers were kind of turned, and then you have this nice bubble. So inside this circle of ports and adapters, you have domain model. Outside is the application layer. And outside there are some adapters to external infrastructure. I'm going to show you how this works in practice to actually use actors for aggregates. And I will also explain what the benefits could be in this particular case. So look at this. See, very similar structure, and I share exactly the same project for the domain. Nothing changes, and you can see it has no dependencies except of this small EventSourcing, which is the aggregate state base class, and the messages. And the messages contain events, so I can't leave without referencing it. It's exactly the same. So look at this vehicle friend. So it's the same thing. So what I do, actually, how I make it work with actors. Well, if you remember the old one, it has these application services, right? So guess what? They were replaced by actors. So that's my view. I see the actor as a thing that lives between the outside world and the domain model. So for me, it's an application service. But funny enough, that application service actually is something that lives. It can be even static. It needs to have an external influence to execute something, a command, and then it just tells the domain, please do that, and deals with the persistence, all this stuff. In my case, it's application service that's attached to the aggregate. So it lives together with it. It never dies. It actually spins up. It lives in memory for a while, and you never need to destroy it. So this is how it works. It's exactly the same. It's very, very close. It just uses some different persistence mechanisms, but basically it is very much the same. So when you need to register the vehicle, this is a command type. You just do this. You call vehicle register. And when you need to register telemetry, you basically do that. I did less operations because I needed to copy-paste a lot, so I didn't spend time on this. But these two main operations that I have for the seed, they are implemented. It's not more than this. It's very simple. I mean, of course, if you look at the behind this vehicle actor, there is a little bit more than I would just say. It's an actor, implement actor interface, but it's also not very hard to understand. So when it starts, it recovers its own persistence. When it receives an event, it actually processes it, or command in this case, and then it mutates the state, and then it persists all events back to the database. So basically, all this cycle of the application service, it doesn't change. The only thing that application service lives together with the main object in memory for a while. So that's the only thing. But what we achieve with that, we actually eliminate most of the reads. So if we look at this, where is this code thing? So this will happen once. And then all these commands will be many. And then you can do many decisions, and you can do many writes. Because you need to read only once in order to actually put the object in memory and let it live there. And you don't need to read so many events anymore. You can, of course, optimize a lot of things there. You don't necessarily need to write everything. Because, for example, if you think about IT scenarios like sensors, if you get a lot of events that are kind of close with temperature and close with speed, you probably don't even want to react on that. You just say ignore them because there's just too many. And if the temperature is relatively stable, you don't want to do anything. Then you eliminate the writes. But in order to make these kind of decisions, you need to know what happens in the state, you know? And if you keep the state in memory, you will never have issues with performance. Because memory costs almost nothing to keep the Proto Actor, especially actors, they're very small. Let's run the sample and the DDD queries, and these are commands. I will run this now. So 5. This is using Proto Actor cluster. It goes through gRPC protocol, so my client actually talks directly to it. Just let me close this one. You need to give me more for these connection issues, you know? So, where is the client? Queries. Here we go. So, 5. So let's see, check if it runs. Application started. Let's expand a little bit. I know you want to eat. Please stay. I didn't eat yesterday at all. So I'm going to seed customers, and customer seed goes through the service bus as before. It doesn't change. But it's very fast. It's just 100 messages. So now I'm going to seed vehicles, and we'll see what happens. So basically you can't see anything. I disabled logging because logging speed slows down the application like 3 times. So therefore we'll be standing here for like 1 more hour just waiting until things start to happen. But what we can see, of course, is that Yeah. When the EventStore is very loaded, it cannot produce anything in recently changed stream. But if you look at the dashboard, first it's slow, and then there is a lot of things happening. So there is a lot of stuff coming in, and the rate of this connection is high. So we probably will be able to look at some streams. Look at this vehicle. And this one. It's probably not there yet, because there are a lot of messages. But I can start queries as well. And if queries terminate, don't blame me for that. I'm not responsible, because it was really last moment change. Queries also converted to actors, and you will see how that works in a minute. So, but it is just an idea. It's a very kind of rough proposal, and you might need to experiment with this and see if it works for you or not. Yeah, it actually works somehow. So these are customers, and vehicles are registered. Let's see what happens in Raven. No, basically nothing. Okay, it's very hard to see anything. Project an event. It should be working. It looks like I opened the wrong URL. Yeah. Okay. Okay, come on. Please don't bug me. Here we go. No, that's actually nothing. But okay. It's a demo effect, of course. So let's see here. So basically, vehicles were actually all sent to EventStore, and we need to project them. But I'm not going to do this now. It just takes too much time. And I hear the sounds of lunch, and you're all probably hungry. Okay, I can't show you stuff. I don't know why. But nevertheless, so basically, all the commands went through. And if you need a proof for that, you can just come to me and ask me, so I can show you how this works. But the last thing what I wanted to mention is that you can also use actors to scale your projections. And how to do that is the following. So what I've done here in this project, and I was doing the changes right before we came here, I actually create a projection actor, the base class. It's very simple. It basically receives an event and persists it to the database using the native persistence of actor model of the actor framework. And here I have what's called a subscription manager. I will show the example of the vehicle item projections. Basically exactly the same as before. It just uses different type of store. Before it was using the RavenDB async documentation, and now it uses snapshot stores, which comes from Proto Actor, but it doesn't matter. It's exactly the same. So you project events to your database. The advantage of this is that read models, the projections will be in memory as well, and they will be doing their own work. If the projection goes down, the projection manager will take, as an actor, it will watch its children and will say, yeah, please restart. So it will always take care of this. If the whole subscription goes down, in a normal version, I have a specific the watcher that looks at the connection doesn't go down. In actor case, I can just say, okay, I don't care. It will die, and it will start again automatically because the framework looks after it. And the latest thing that I actually didn't start to implement, and it's a very interesting opportunity to look at, and you might, if you really get into it, I know it's kind of overloading, you can consider the read models are also actors, the individual documents. Because everything we do here is an update. We read something, and then we write something again. We read and write, read and write. What we can do, of course, is that the read models itself are actually in memory. I think it's already there. I think it's there. This thing actually does this. It's just an ID that doesn't calculate correctly. So if the read model lives in memory, it actually can decide what it needs to project. So So for example, if the data comes that it doesn't have interest in, it doesn't do anything. You don't even need to load any document. You can make decisions based on the state of the read model that lives in memory. And using actors opens you a lot of opportunities. For example, if you're making decisions in memory and you kind of categorize your events by very important to not that important, for example, telemetry events that just tell you speed and temperature, you might not consider them as important unless the vehicle is on fire or the vehicle is overheated or it's speeding, because then you need to do that. So you might trigger these changes like what we did, remember? With diagnostics of sensors, what we did is like, if the sensor detects a faulty state, then we really persist an event. If sensor actually recovers, we persist an event. But if the sensor doesn't do anything, it's just normal, we kind of, now and then we persist. And if we don't persist it in time, or it will break, or the actor will die, we don't really care. So we need to be very careful about thinking, okay, how important our events are, do we need to persist all of them or not? But in the classical event sourcing, when you actually have to persist everything because you need to know what happened before, you have to persist. In an actor model, you don't have to persist. You just keep everything in memory. And you can also have, I mean, it will not guarantee you from data loss when you crash, but if you persist important stuff, always, transactionally, then you're fine. And you just ignore certain things because it could be deviations of stuff, you know, small changes now and there. And of course, you can actually make decisions based on data that is stored in memory, which is much faster than looking into the reading events from the store every time. And of course, if you build read models that are kind of rich, a lot of data from different streams, then you don't need even to query database. We have this system that works with actors, and we build an API on top of that. So what the API does is basically just goes by ID to single actor and asks for its state. And then you just get it. You know, when the actor starts the first time, the response is usual like 50 milliseconds or something like that, maybe 100, like usual web stuff. When we call the actor, when it's already running, the response time is about 0.2 milliseconds, 0.5. So it's really, really fast. You know, I really wanted to draw for you, you know, I'm a beautiful artist and I draw perfect pictures, but it really sucks that the connection didn't work, so I apologize for that. The demos that I did, there are a lot of stuff in there. The code, a lot of code is very close to production state with logging and checkpoints and a lot of stuff. Even Grafana or Prometheus metrics are taken in. So I will make it public probably today. And if you follow me on Twitter, I cannot draw. Sorry about this, but I can write. So let's see how that works. Just look at it. Then I will publish this today, and I will stay here for the rest of the day and to the panel session, so that's fine. And I wanted to tell you that a lot of things that I'm talking about are also available in my repository for the book. You see, I can't even connect to GitHub. It's completely down. The internet just doesn't work. I can't say it's my fault, but I can't blame anyone as well. So just try to do something like, you know, what could it be? Text editor, okay? This is the last tool, last resort. New document. And it's very, very small, you see? I'll do like this. Okay, so I will paste. This is the repository for the book. Okay, here we go. And basically, if you look at GitHub on my account, you will find this repository later on. So it has several things. If you look at the structure, It has the shared stuff. It has one stuff that is called a classic event sourcing with read and writes, and one folder with actors. And also one folder with clients, and clients, one client is seeding using RabbitMQ, and another client is seeding using actor model. So the book that I'm writing is about event sourcing and DDD, and actually practical application of this stuff, and a lot of things that I was talking in the first part without touching actors is actually described there in a much better detailed way than I can manage to do it on stage. So if you're interested in that, a lot of practical advice is basically battle scars that I described. You know, I was writing this book with intention that if people come to me and ask me questions about this, and because they come to me like several times a day, just say, you know, page 25, you know, page 167. So this kind of stuff. It's really a lot of things that we learn in production, and a lot of stuff that kind of gotchas and all the small things and big things that you need to know if you want to bring it to life. But the whole thing is awesome. I mean, trust me, if you do event sourcing, do it more. If you don't do it, try to do it. And if you don't do actor model, and you have millions and billions of events in your system, that's probably you're doing something wrong, or you need at least to try. And I have to say that through our solutions, we counted last month, it was 5 billion events per month. It's not that much, but the company is very small as well. So it's kind of good. And we only have 5 pods in one Kubernetes cluster, really weak. So it's reasonable. It's really good, I think. So okay, if you want to find me and you want to talk to me or whatever, just give me a ping on Twitter on this account, and I will talk to anyone who comes to me about anything. Thank you very much. I'm sorry about the technical issues.
Thank you very much for your speech. We have a small gift for you for being here with us.